QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Consider this function. First question. What is the vertex of the graph of the given function? The vertex of the graph is at 3/2 and -1/4. Next question. The concavity of the graph opens in which direction? The graph opens upward. And to the last question. What is the maximum and the minimum values of the given function? The correct answers are, for the maximum, it's a positive infinity, and for the minimum, it's -1/4. Did you get 3/3? If not, please continue viewing this video. For this function, f of x is equal to x squared minus 3x plus 2, its graph is also known as a parabola or a parabolic graph. The graph looks like a portion that is either increasing, then at one point it changes its direction to decreasing, or the other way around. That point where the graph changes its direction is called as the vertex. This is one of the concerns in this video, including the concept of concavity and the maximum and minimum values of the given function. Now these 3 are joined together because we can draw conclusions into the other 2 with using the concept of the vertex and its needed requirements. To solve for the vertex, we need to give the correct coefficients of this function. The coefficients are similar to how coefficients of quadratic functions are structured. We have the a, b, and c coefficients. For a coefficient, this is the coefficient of x squared. And since it's just x squared, you have your 1. Your b coefficient is the coefficient of your x. And it's not just a 3, but rather it's -3. Take note that the operation before the term becomes the sign of the coefficient. And of course, the c coefficient, or our constant, is 2. Using these 3 coefficients, we can now determine the vertex, or again, the point of inflection, or the point in the graph where the graph changes its direction. Since it's a point in the Cartesian plane, we know that it contains x and y coordinates. The x-coordinate of the vertex, without even using other methods, can be solved with these coefficients, -b/2a. We just simply plug in the values for b and a coefficients respectively, and whatever be the result, that's the x-coordinate of the vertex. For a y-coordinate, we could also have 4ac minus b squared over 4a. And again, we plug in the values of the coefficients. This is squared, right? And you will have your y-coordinate. Or, if you have problems in memorizing this, simply solve for the x-coordinate, and whatever be the result for this, use that value for our function, and the result would automatically mean the y-coordinate without even using this set of coefficients. So starting with x, we have -b/2a. Take note that our b is already negative, so this would mean negative of -3 over 2 times 1. So this would mean we have here the result for x, the double negative property of our numerator, so positive 3 over 2 or positive 3 halves. Now, don't worry if your coordinate or x, even the y coordinate, are in fraction forms because they are still acceptable for they are real numbers. Okay? What we need to do now is to use this value for x in solving for the y coordinate of the given function. You have x squared minus 3x plus 2. So you will have here f of 3 halves, meaning you will be changing the values of x into 3 halves. So you have here the square of 3 halves minus, that's a square, right? Minus 3 times 3 halves and plus 2. Again, you just need to review your fractions and you don't need to worry about this. The square of 3 halves is 9/4 minus 3 times 3 is 9 halves plus 2. LCD is 4. So you have here 4. That's 9. 4 divided by 2 is 2. Please review these processes. Times 9 is 18. Again, 4 divided by 2 is 2 times 9, 18. The operation is subtraction here. And then 4, of course, this is 1, right? 4 divided by 1 is 4 times 2. You will have your 8, and that's plus. In short, the value for your f of 3 halves is actually the y coordinate of your vertex, which is equal to 9 minus 18 is negative 9, and then you have your plus 8, so you have negative 1/4. Again, let's do it again. 9 plus 8 is 17, that's why minus 18 you have negative 1/4. This would mean your vertex or your graph changes direction in the vertex with the coordinates 3 halves and then negative 1/4. If you're going to plot this in your Cartesian plane, 3 halves is 1 and 1/2. So if this is 1, that's 2. So you will have 3 halves here. And if this is 1, you have negative 1/4 somewhere here. This is your vertex. Now this vertex again is where the graph changes its direction. We are done with the vertex. Let's proceed with the concavity. The concavity could either be upward or downward. Using this vertex, your upward graph may look like this, where it goes down from here to there, or it decreases from left to right. It decreases from here to there. Once it passes through our vertex, it changes its direction and then it goes up. That's opening upward, or it could also open downward. So it goes up. Once it reaches that vertex, it goes down. Of course, it's a parabolic graph. It's a parabola, so we need at least 5 points to graph our function. But since we are not necessarily graphing here, we are to solve for concavity and the minimum and maximum values later. Let's just focus on this. But if we have 5 points for parabolic graph, your center will be the middlemost, and you just simply apply those points to see the correct and more appropriate graph. For concavity, again, it's either upward or downward. We can use this coefficient here. The A coefficient tells us a lot about the graph. If A is greater than 0 or a positive number, our graph should open upward. If our A is less than 0 or it's a negative number, the graph opens downward. In this case, since A is positive, it fits this criteria, our graph should open upward. So just for representation without properly considering other points, the graph may look like this. Right? It goes upward, and this means it goes further without bound. With this, since we already identified that it opens upward and we have this vertex here, we can now determine the maximum and the minimum value of our function. The maximum and the minimum value patterns on the values of your y or your f of x. Meaning, look at the graph, analyze the graph, consider the vertical movement of your graph from here, or it's still extending further if you're going to extend more values of x here. So just for this, it goes down, and once it reaches this portion here that corresponds to your vertex, it goes up again. So in short, it goes down. Once it reaches here, then it goes up. This is the structure of the upward concavity of the parabola, which also means that this portion here, according to your y-axis, is the least point because it doesn't have other points here which corresponds to other values of y. This would mean the exact value between the two is your minimum. The minimum value is the y coordinate of your vertex. Why it is y or f of x? Because that's again the concern of the minimum and maximum. So once you have your vertex, no matter what the x value here, of course you will be using that to solve for y. Simply focus on y, so that's negative 1/4. Now, picking that value of y, which is negative 1/4, it could either be maximum or minimum. But since the graph is opening upward, that is your minimum value. If ever, just if ever, your graph opens downward, that point is actually the maximum. But since it's opening upward, that's minimum. What happens now to your maximum? Notice here, this is not the boundary. This is just a representation because your graph still extends further as it has more values of x here and here. This would mean the maximum value is still extending towards positive infinity. These two were made possible, analyzed possible by the concept of your concavity as it opens upward and the y-coordinate of your vertex we have done solving earlier. Again, no need to worry about the fractions, just simply work it out and review for that. These are the three concepts and answers for this QuadQuiz. Subscribe now!